Okay, here's another quick video talking about working with patterns, identifying maybe an equation from a table of values or from some points on a graph. So here's the same information presented a couple of different ways. Here's a graph with 2 points on it, point A and point B. Or here's a table of values with 2 spots given, this spot and that spot. So when x is 2, y is 4, that shows up on the graph here as when x is 2, y is 4. That brings us to point A. Or for our second one, when x is 4, y is 5. When x is 4, y is 5. Where we would connect these is right at point B. So same information, just shown visually over here and in a table over here. If we're trying to figure out an equation, a way to write this down, we're looking for a formula, and the formula will usually look like y equals something. One thing that we can look for, there are a few ways to do it, but I'm going to show you just one right now, is to look for the change in the x value and the change in the y value. So change in x value can mean how far do we go from here to here, but only in the horizontal direction. So only in the horizontal direction, only on the x-axis. What change have we made? So we'll just label these 2 points here. A is at 2, 4. The x-coordinate is positive 2, the y-coordinate is positive 4. And B is at 4, 5. The x-coordinate is 4, the y-coordinate is 5. So just labeling those. In terms of the x, we could say we've gone over 2 steps. Or we could look at the x-coordinate, which is 4 here and 2 there. So we could say that this is 4 minus 2, which is 2. So we could either subtract 4 minus 2, or we could subtract 4 minus 2, or we could count 1, 2. Either way, we get 2 steps. For the y values, we've got, well, another way to look at it, right? We've got from the A to the B, we go up that far. So just in the vertical direction, we've gone up from 4 to 5. So we've gone up 1 step. Or we could say we look at the y terms. So here's a 5 and here's a 4. The difference between them is 1. Or we could subtract 5 minus 4 and get a difference of 1. All of these ways get us the same answer, which is talking about the change in the symbol delta. The same delta you might see at the mouth of a river. It's the Greek letter D, means change in. So change in x is we look at our 2 x values, 2 and 4, the change was 2. Change in y, we look at our 2 y values, 5 and 4, the change is 1. And if we wanted to find a spot in the middle, say we wanted to find what happens when x is 3. Well, for every 2 steps that x changes, y changes by 1. So for every 1 step, so for each difference in x of 1, how much does y change? Well, I've gone 2 steps before and it changed by 1. So halfway in between A and B, halfway in between there, let's just pretend like we can draw a line. Halfway in between there will be right there at 4.5. So it looks like we go 1/2 step up in y for every 1 step up in x. We can look at this in this form, change in y over change in x. We can call this by a different name. We can call change in y rise, and we could call change in x run. These are 2 terms that we use when we're talking about slope. The slope of a line, positive slope, negative slope, no slope if it's horizontal, undefined slope if it's vertical. So change in y, change in x. We can also write change in y as we did, the second y point minus the first y point, and the second x point minus the first x point. So this would be here x2, and this would be x1, and this would be y2, and this would be y1. We label them from left to right. So point x1, y1 go over here, x2 and y2 go over there. If there was a third point way up here, we would call it x3 and y3. So here we did y2 minus y1, which was 5 minus 4, and x2 minus x1, which was 4 minus 2. So 5 minus 4 was 1, and 4 minus 2 was 2. That's the slope of this line. It's also telling me how much the y changes for every one step on the x. So this is the generalized formula for this example and for any example of a graph with a line. So if I go up by one step, it's 4 plus a half, right? So I go up by 1 here, here I go up by a half. So 4 plus a half is 4.5. I go up another step here, well, I go up another step here, up another half. So these ones are increasing by 1, and these ones over here, I'll write that up here, these are increasing by 1, and these are increasing by a half each time, 0.5 each time. If I went back and I said when x is 1, what's y? Y is 3.5. So I'll subtract, I go down by a half. When x is 0, y should be 3. And if I extend that line that we drew before from B to A, and I keep it going, we can see that when our x value is 0, oops, get back in there. When our x value is 0, so I haven't gone left or I haven't gone right, then where are we on this graph? We're right here at 3, or would be if I could draw better. So in this case, if we wanted to write out an equation for this line, we could write out in a form, which we'll talk about later, called the slope-intercept form. M is the slope, which is this value we've calculated here, so that's 1/2. X is just x, and B is the intercept. So M is slope, and B is what's called the y-intercept. And where we would cross the y-intercept is at 3. This is one way we could write out the pattern that we think that these 2 points here might follow. We'll look at more examples like this in class 2.